Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. In this video, I'm tackling a question that a student sent through from a recent exam they took on complex numbers. So the question has two parts, and it tells us to consider omega is an nth root of unity, and you may assume that 1 plus omega squared and so on, all the way up to omega to the n minus 1 equals 0, or in other words, the sum of the roots of unity add up to 0, which hopefully is something that you're familiar with. Part 1 tells us hence or otherwise show that 1 plus 2 omega plus 3 omega squared and so on, all the way up to n omega to the n minus 1, that is equal to n on omega minus 1. And then part 2 says by expressing z to the n minus 1 as a product of factors, deduce that 1 minus omega times 1 minus omega squared and so on, up to 1 minus omega to the n minus 1 is equal to n. Now what I might do is I might tackle each of these parts in separate videos, because whilst they're all related to this initial set of facts that we're told, the technique we need to use in part 2 isn't really a continuation of part 1. We don't need to rely on what we did in part 1. So really they kind of stand alone. So I think it makes sense to just treat them separately in separate videos. So starting off with part 1, we're being asked to show that 1 plus 2 omega plus 3 omega squared and so on, up to n omega to the n minus 1, that's all equal to n on omega minus 1. And we're told that omega is a root of unity. So what that means is that typically we have it kind of expressed in the form z to the n equals 1. Or you might see it as z to the n minus 1 equals 0, which is the same thing. And we kind of know that as a polynomial with n as the exponent, that there'll be n solutions to this. So the solutions here would be 1, omega, omega squared, and so on, all the way up to omega to the n minus 1. And, you know, there's a whole bunch of ways you could then have questions thrown at you in the context of what are called roots of unity. Often you end up drawing a diagram that involves the unit circle, and that's why we call them roots of unity. It's all driven by the fact that it's a 1 here. But the tough thing about this question is we don't actually need to do that. Where you might have learned, you know, start by defining z as cis theta and then working out what theta is and drawing up your diagram. Actually, whilst that's a common technique for roots of unity questions, this question doesn't require that. So I think, as we'll see, the kind of math you have to work through isn't that difficult, but the difficult part about this question is knowing where to start. And I think it's one of those questions where once you've seen it once and had it explained to you, then you just add it to your toolkit and you'll be ready for it if anything like this ever gets thrown at you in an exam. But for the first time encountering a question like this, it can be quite difficult. We are told that we can use the fact that 1 plus omega squared all the way up to omega to the n minus 1 equals 0. Or in other words, the sum of these solutions adds up to 0. I think there's actually two ways you can prove this. I mean, there is one way involving calculus, because when I first looked at this, I noticed that this looks essentially like a derivative. But whilst that technique did get me to the right answer, it didn't rely on this result. And so the approach I'm about to show you, it does rely on this result. So I think it's the approach that the question writer had in mind when they were coming up with this question. So it's the approach that I'll work through, but there are other ways you could also tackle this. So the place to start, and it's probably not an obvious place, which is what makes this question hard, but let's just let x equal this expression on the left-hand side. So 1 plus 2 omega plus 3 omega squared all the way up to n omega to the n minus 1. Now the reason that's helpful is now what we can do is we can multiply both sides by omega. So let's see what omega x equals. So we'll get 1 times omega is omega, plus 2 omega times omega would be 2 omega squared, plus 3 omega cubed, and so on. Now, I might just write the last two terms here. So we'd get n minus 1 omega to the n minus 1 plus n omega to the n. So that's kind of what we get when we multiply both sides here by omega. And now that we've done that, we can take the difference between these two things and see what we get. And if you're kind of wondering, well, how do you know to do this? So I'm about to go x minus omega x. And what could have driven me to even think of doing that? Well, what gave me the idea is over here in the right-hand side, the result involved omega minus 1 in the denominator. And I can see here that I'm kind of going to get, I'll get a 1 minus omega, but I can easily deal with that by multiplying by negative 1. So I kind of know I'm going to get something, hopefully, that can simplify to this. That's kind of what originally sparked the idea. And again, admittedly, that's not something that would jump out to everyone. And particularly in the pressure of an exam, it would be quite a big ask to expect to be able to come up with these kind of ideas under that kind of pressure, which again is why you need to be practicing these kinds of questions before the exam so that you can kind of just go in and smash it out and not have to come up with too much original creativity. Anyway, let's work through this algebra. So the x would be 1 plus 2 omega plus 3 omega squared, and so on, up to n omega n minus 1. And now with what we're subtracting, this bit here, I might just offset it to make it really obvious what we're going to get. So we'll get minus omega minus 2 omega squared minus 3 omega cubed, and so on, up to minus n minus 1 omega n minus 1 minus n omega to the n. And the reason I think offsetting it like that is helpful is because we can see we're going to get 1, 2 omega minus 1 omega is omega, 3 omega squared minus 2 omega squared gives us omega squared, and so on. We'll keep getting that, and then we'll get up to n minus 1, will just give us 1 again, so we get omega to the n minus 1, and then we've still got this left at the end, so minus n omega to the n. And now, hopefully, you can see the link between what we've ended up with and the result we were told to use. Because this whole bit here, the 1 plus omega squared and so on, up to omega n minus 1, that's 0. So it disappears. So we can just write our right-hand side as minus n omega to the n. Now left-hand side, I might just do this factorization. So I'll factor out the x. We'll get 1 minus omega. So now I can bring that over. So we'll get x is equal to negative n omega to the n on 1 minus omega. And how I can simplify this is I can actually say that's equal to negative n on 1 minus omega, since we know z to the n is equal to 1. That's kind of the starting point of all this. And if omega is a solution to that, that means we can substitute omega in and it'd be true. So omega to the n is equal to 1. So this omega to the n here is just 1. So you can kind of drop it off in a way. And this is where I'll just multiply by negative 1 on negative 1, just to get this in the exact form we need. So negative n times negative 1 is n. And 1 minus omega times negative 1 would get us omega minus 1 as required. So yeah, that's how you tackle that question. It all kind of came down to just having the idea to kind of take the expression on the left-hand side and multiply it by omega and then take the difference. So not something I'd imagine most people would probably just come up with naturally. It's not an obvious thing to do. as I mentioned before with roots of unity, we're kind of trained to just start by defining z and going through the motions. So I think the difficulty with this question is we weren't just going through the motions. It was kind of almost, it was an algebra question hidden amongst the roots of unity question. And you still had to understand some of these roots of unity ideas. You know, what are we really dealing with? But the real I guess, skill required in this question was here, just kind of algebraic techniques. So hopefully you found that helpful. If you did find that explanation helpful, please be sure to give it a like. And if you're the kind of person who wants to keep their finger on the pulse with the kinds of questions other students are struggling with, please be sure to subscribe to my channel so that you can stay in the loop. Alright, tick boom.